Hello, everybody. This is Larry. 40 seconds to the beginning of the 165th Leetcode Weekly Contest. Wish me luck. It's 9:30 on a Saturday in New York. Yeah, gonna have some fun. Feel free to skip ahead if you watch on YouTube. I guess that's where else would you be. But yeah, if you like it, leave a comment, press like, subscribe, all that good stuff. If I didn't do if I didn't do well, then also leave a comment and encourage me for next time, I guess. But we'll see. Okay, 8 seconds. Here we go. Got my lucky hat. Hopefully it's lucky, otherwise I'm not wearing it again. So cool. Yeah, jump right into it. Yeah. So I mean, I think immediately I was thinking tic-tac-toe. Is there anything tricky? Uh, didn't really seem like it. It seemed like I just had to follow the rules. I didn't have to guess anything. I think my first thought was actually that I might have to write some game theory stuff. But I was like, this is easy, so that's probably not it, right? And then now I'm just thinking about how to kind of do the simulation. Yeah, immediately I'm just setting it up. And here I was like, okay, let me figure out how to do the serial values. And instead I just set it to -1 so I could do the thing with the turn where, we just flipped a bit for turns. But yeah, right now I was debating how to kind of attack this farm. Um, and I was like, should I try to be a little bit clever, trying to be a little slick? I was like, no, there are not that many cases. Tic-tac-toe is, there's horizontal, vertical, and then diagonals, right? So let's just kind of brute force that out. Um, and of course, when you do brute force east or like not even brute force, the fact that you're typing everything out manually, there are a lot of margins for error. So I was definitely very scared of this. Um, and then as I was thinking about writing the function, I was like, oh wait, do we have to care about? Yeah, just to make sure that it is not equal to 0. Oh, sorry, it's not equals to -1. And then I just figure I have a helper function. Just running out the cases. It's pending, and I was like, oh wait, there's a draw. What's a draw? Well, I was thinking about just like checking everything. I was like, oh, that's just if you have 9 moves, right? So but yeah, very. I mean, I copy and paste, but very carefully copy and paste. Definitely very mindful of the possible silly mistakes. And then I was like doing diagonal. I'm like, wait, how did I do the diagonal? That doesn't make sense. So then I just kind of, took it out. But again, this is very manual, so I was doing it manually. And it's just about getting all the cases. Some of that comes in handy a little bit with experience in that you recognize how to do one diagonal one of the diagonals is x is equal to x, or like x is equal to y, sorry, and then the other one is x and y, x plus y is equal to n, which in this case is 2. X plus. I ran it, and I was pretty confident about it, though I still want to double check, just because sometimes I don't know if I'm misreading a case in general. So this checks me a little bit. Sometimes that still is not good enough if you don't read the problem carefully. But in this problem, it seemed like it was okay. So yeah, very good to go. And then now number of burgers. Oh man, this is a tough one for me. I think one thing that I'm looking for is that I actually submit the problem by accident. But you'll see that in a little bit. I didn't even notice until later, so maybe I could look for it. An empty solution, right? So there should be like a gate for like, hey, if you submit something that literally doesn't pass like a very basic case, then you didn't really submit. I mean, some cases they do, some contests they do a pre-submit phase, but it is what it is. Sometimes you eat it. But yeah, the first thought that I have seeing this contest, seeing this problem, and I kind of wrote it down on paper to kind of figure it out a little bit, was that I thought it was going to be some kind of GCD type thing, where you have to get the greatest common denominator. But what I noticed while I was writing it out was that C is always 1, or cheese. Both the jumbo and the small burger only uses 1 cheese slice. That means if there's X jumbo burgers, there's cheese slices minus X small burgers. And I make a, did I submit yet here at this point? I guess not. And I don't even need that shortcut. I never need to save 5 seconds to submit. So I think I need to get rid of that shortcut. But yeah, but I think for here, my one critical mistake is that I didn't really think about. I was rushing this a little bit too much. I wanted to finish really high up, and the only way I do that is by just shaving corners a little bit. I was like, okay. I actually think I pulled out a calculator. I was like, 10 to 7 is 10 million. Even linear search should be enough, though. And I just didn't think about it. I thought it'd be fast enough, but it did run into an issue, as you see, with time limit. And the reason is because I guess the test cases are enough for that to be a reason. I mean, it's a very simple code, but and I don't really know what happened, but yeah.
I click on submit.
I guess I always submit it by accident. I'm guessing it's the shortcut because I clearly didn't click on it.
Probably clicked on it by accident.
And I think right now, even though I try to keep it together, I was very unhappy, obviously, when you give away 5 minutes for no reason. And a little spoiler alert is that you do the math, I gave up. I went from would have been like 70th or so or 75th or so to 107th. So that's that's kind of a big jump to give for no reason, right? Like I don't even, you look at the stream, I don't even remember seeing this. So and this, and it's the first time that in a while that I was wrong on a problem for a little bit. And this time, yeah, it's a little tricky because when you run the code, the number of test cases does matter, so you don't have transparency to it. Because when I run code locally, it seemed okay, right? And that was for 10 million, and that's clearly fast enough. I think it took me only an extra like 5 seconds to be like, okay, well, this is actually binary searchable. So I really should have done that to begin with. I was a little lazy and just really rushing it, right? And I ate it here. And I think right now I was just like, well, in a way, I think it relaxed me a little bit in that I was like, well, now I'm no longer in play for play. Like it's very hard to get top 10, top 20 if you have a submission error anyway. So now I have 2 submission errors. So yeah, I mean, unless the problem set is very hard, but if this problem set is very hard, then I might still not finish it anyway, right? So yeah. And then the binary search equation is that, well, how many tomatoes do you require given X amount of or X number of jumbo burgers, and that's what I do here. I mean, it's really straightforward binary search, and I think some of it, I don't know, I was a little not in shape. I just gotten back from the outside, and there's a little rustiness here. I mean, that's essentially it. Well, there are a couple of typos. So this is about 10 minutes in, or 9 minutes in, 9.5 minutes. And this really should have been it. This should be the code that I submit. Mine is like a very
I
quick
need to disable my shortcuts because I think I clicked on the shortcut for submission by accident.
But you could probably already spot a typo, and I don't really return anything. But like, if I was good, this was only a minute away, right, at most. And again, here's another typo where I just copy and paste the head plus 5. I guess I wanted to say that I relaxed a little bit, but I still rushed this a little bit in that I really wasn't thinking. I was typing out a template in my head of how a binary search is in general, but I didn't do it, right? And this ends up never giving me a right result. Oh, wait. Well, first of all, it was time limit because I rushed my thing and then I was like, oh, mid. And it took me a little bit to spot this too, even. For a second, I mean, you see me actually thinking that painful to watch in retrospect, right? I actually thought like I got it right, but that because a lot of the times in binary search, sometimes you just mixed up the signs for your search. I didn't think that was the case here, but I was like, huh, that should terminate 0 and 3, if nothing else. And I was like, oh, I'm setting the mid to whatever. So that's mistake number 1. Okay, it terminates, but it doesn't give me any answer. Why is this wrong? Well, the second while loop, it doesn't go back up. I just didn't notice this for another 2-3 minutes. So that is obviously also really sad. But unfortunately, at this point, I thought that there was something wrong with my binary search. And because I was doing multiple inputs, I was confusing inputs. I thought that for some reason the mid was getting updated. I don't know. It's a whole thing. But the idea is that I was just being dumb. And I was also just double checking that, like when I was doing something weird. I was like, no, that should be okay. And unfortunately, this goes on for another 3 minutes on the debugging. And in this problem, I probably spent about 2-3 minutes coding the core process, even twice, by like 4 minutes if you want to count that. But spent 10 minutes debugging and then 10 minutes on penalties. So this problem cost me 20 minutes of unnecessary time out of a 43-minute finish time score. So, you live and you learn, but sometimes silly mistakes, right? Because I mean, I obviously knew how to do it, but even then, I got a little bit strategy-wise greedy and trying to shave off at most a minute, not doing binary search with a linear search. Like, yeah, it takes me a little bit longer, and there's debugging possibilities is also why, because with a linear search, I knew that like I'll get it right correctly, but still. Like I was probably pushing it, and even on a meta sense, like that was just a little silly. Like, it's a medium really going to be linear search? But that's it. I have done contests in the past where it was easier than I thought on a medium. Like it required a more naive, or it didn't require, but like a more naive algorithm was good enough. So, yeah, it's sad. And I'm still struggling with this one. I'm just like, maybe the total function is wrong, because like maybe there's some like scope creep type thing that I missed. But we're fine. I spot it, maybe. Oh, I was debating of getting whatever to see to change the answer. I mean, in debate I did, and it didn't So I was like, huh. But I still just couldn't. I think one thing is when you have a template and you deviate from that template, the mental template, it's hard to debug because you're like, oh, you just assume a lot of things that you almost never get wrong. Like, and I, at least on the typo aspect, this while loop, I probably get wrong like, I don't know, 1 out of 50 tries, right? 50 problems. And in those 2% of the time, you just little sad. I still don't get it at this point, clearly.
Kind of.
So again, I took a lot of time here. Oh, and then now I was like, okay, maybe it's there. I printed out, and then I was like, why is this not printing? And it's because the while loop, even though it took me an extra thing. I guess at this point, I was resigned to not getting a good ranking. That ended up being okay. I mean, if things don't go your way and you still finish just a little bit shy of top 100, you're okay. Because there are a lot of things that went wrong for me in this contest. Okay, and then I was like, okay, this is good. I'm just gonna submit. If it's wrong, then yeah.
Silly
Kind of square submatrix with all one. So I do explain this problem. At least the reasoning about this. I do explain it at the end, so skip ahead if you want to listen to that. But right now, I'm just thinking, well, counting this number of square, or sorry, the maximal square is a known problem to me. I think it's a, I mean, it's even a Leetcode problem, like the biggest square that's within a submatrix. And in that one, you have a dynamic programming problem, and each kind of cell tells you what the biggest square is for that cell, where it's the lower right corner, or however you do the math. And then from that, I just had to think it through. I also was wondering if I could do some n cube thing where, just like I know how to do that DP, but I was like, well, how do you get to counting from that DP? And I was like, maybe I could just count the number of, like, how many size 1 squares are there, how many size 2 squares are there, and so forth. But I wasn't able to, I think I just used the calculator, and I was like, okay, 300 cube is like 27 million. And I just did a problem where 10 million or whatever it was is like a little bit too slow. So I wasn't going to risk it. Right now, I'm just setting the boundary sizes of number of rows and matrices. But yeah, this is 7DP. I think the decision that I was trying to figure out what to do here is whether to use the matrix itself. I'm like, matrix is already given to you. I don't have to reallocate and re-copy over and everything. So let me just use it. But yeah, and then I was thinking how to do the boundary conditions. It's been I mean, I knew the recurrence, but even with the recurrence, the edge cases, I was like, okay, do I need to care about things that happen on like the top row or leftmost column or something like that, right? But yeah, that's what I'm going for, and I was like, okay, we should only do this if though this is technically not necessary if you construct your set node cases correctly, but I just didn't want to think about it that much. There are enough things to think about. But yeah, this recurrence, I'll put a link on the comments or description to the other problem, and then I think I try to explain it a lot more. If not, then my bad. Leave a comment and I'll try to explain it in text. But yeah. But I don't know how, to be honest, I don't know how I would solve this if I didn't already have seen this similar problem before. So this gives you the max square that ends in that lowest cell, and then I was like, okay. I think around here, I mean, I might have thought about this before, is that I made a note, and I wasn't sure about this, but I was like, okay, you could actually just sum up this matrix because let's say your max is size 3, right? That means that the 3 squares that end on that as a upper right corner or lower right corner or whatever. Um, so, so yeah, I think getting the first one right gave me enough confidence, and still gonna do the second test to just for a little bit more confidence, and then I submit it. And actually, the funny fact is that that was my shortest
12 people
shortest problem solved for this contest. So who knew, right? The third problem. Palindrome partitioning, I mean, I think as soon as I saw this, I knew it was dynamic programming just because of partitioning and stuff like this. The only question for me is what kind of programming, what kind of dynamic programming it is. I did a quick refresh to see, because I know that I'm a little bit slow. Usually when I'm fast, like no one have it accepted, or maybe one person, because not because I'm faster than everyone else, but because people quite ahead of me, they haven't submitted yet. Like no one usually people haven't finished 4 problems before I finish, just as I finished 3, maybe that's out again. But at least when you're fast, you get a pace for it. This problem clearly not the case. I saw that 12 people got it accepted already, so that means it should be tractable because we're only 20 minutes in at this time. So I'm thinking about it. Yeah, I think I knew how to do this. Like I knew the states were roughly speaking some sort of subsequence, and then the k that is left. Um, and then I was just figuring out how to write the DP. I still need to be better about writing the DP in Python 3. Long time viewers will know that sometimes I switch languages, and in the past there was a contest where I did it in either 3 or 4 different languages. But here I try to be like focus on one language and really get to know it. And initially I was like, like I thought maybe there's some like subdivide from, but I'm like, oh, actually no, you only need, it's a prefix type dynamic programming. So I just start from 0 and so then the recurrence is the best or the minimal that you have to change with the prefix of x or you're on the x character with left number of partitions left. So that's how I thought about it. And overall, this is very straightforward. I think it's actually it's now that I think about it, it like is essentially shortest path in the DAG, which is an n square e algorithm, or n times k in this case. And k and n both being less than 100, I didn't really think about it that much. Though in this, well, I want to say it's n times k, but technically the cost function is of n. So, but you only calculate each one once. So it's a little bit more complicated than that. It's probably n squared k now that I think about it, just because the calculation function is not all of 1, but not a big deal when your n is 100. So I don't think I actively thought about it, to be honest, until this point. I just kind of like have a hunch for it and I went for it as soon as possible. That said, so at this point I'm 5 minutes into the problem, roughly, and the sad thing is that in theory I should have gotten this in another minute or so, but I end up taking another 10 minutes, just due to off by ones and silliness. Actually, the DP part of this was pretty sure, like I got it correctly, pretty much. Like there's no off by 1 here, which is actually sometimes shocking. Sometimes it's a very common thing for me to go off by 1 in DPs, so I'm mindful about it, especially on these things. But the funny thing, and sometimes, I mean, and that's why I say that I don't think I had an exceptional contest, by all means, But given that I made so many things, like so many things went wrong at the same time, and when so many things go wrong at the same time, and you still finish 107, I guess you take it, right? Like there'll be good days, there'll be bad days, and when your bad days are still just almost top 100, it's not the worst thing in the world. But yeah, now I'm just doing base case, and I'm like, oh, with left is 0, actually, you cannot convert anymore. So actually just make it a billion or whatever, it doesn't really matter. And also, obviously, if you get to the end of the string, then you just 0. It doesn't matter what left is or how many partitions you can have left. You could do better, but your dynamic programming would have taken account of that. And the funny thing is that writing the cost function, which just takes the left index and the right index and then calculate the number of differences in palindrome, that's what I end up spending the next 7 minutes writing and debugging. So you could say that I spent 7 minutes on the Yeezy, like on the equivalent of a Yeezy. Right? Like if you have to write this cost function of like, hey, here's a string, given the suffix, like return the number of characters you have to change. That's easy. And unfortunately, I took 6 or 7 minutes because and some of that, to be honest, is me not being familiar with Python. Also, I could have done this in a different way. I just didn't like. I was like, okay, let me just get the substring and then do it that way. Actually, I could just have done like starting from left and then keep on incrementing and then counting it from right as well. But I only thought about this now, so I didn't think about this during the contest. I was trying to do at this point. I knew that like for this part of the function, I could just do something naive, as long as I don't have off by 1, which I did. So that I didn't really worry about performance or even just like minor catching ups. And I tried to be too Pythonic. I think actually this part is right, but because I think the thing is that when you're not familiar with language, sometimes even the things that you're right, or yeah, even the things that you do that are correct, because you're not familiar, you have doubts about it, and that's where practice comes in. When you don't have doubts about it, or when you have less doubts about it, then you debug other stuff, right? Sometimes it works against you, like in the last poem or 2 poems ago, where I have a blind spot to that while loop. But in general, that's how I would think about it. I spent a lot of time because of this and the cost function, because I was like, okay, a lot of things were just wrong, because I have an off by 1, and that off by 1 truncates the string by 1. And so like the cost function was returned 0 very often, and then therefore the cost function is 0 a lot, allowing a lot of answers to be 0. I do eventually fix this. I think I try to debug the dynamic programming portion a lot, the memorization a lot. It was not the problem, so I do spend the next about 6 minutes on this. But to be frank, the only thing that I think I end up changing is that if you look at the string construction on, I think you can't see it right now, but like either line 11 or 12, should go from left to right plus 1, because the right bound is not inclusive, and I wasn't sure about that. So, but yeah, that's kind of all I have for this contest. Larry will talk to you in a couple of minutes. Just watch him debug, and I wasn't sure if I was off by 1 again. But yeah, cool. Thanks. See y'all. I mean, the other Larry will see you. Keep on. Stay tuned, though.
Oh my god. I don't even know if that's right. Yeah, that's right.
What a painful contest. That second submit sucks. And the first one, I mean, I deserved one of them, but I didn't. I don't know. Like I said, I did a shortcut thing, and even this one, okay, I knew the answer. I just off by one, which I guess I should have known. But overall, kind of a crappy contest. But 231st, people. I mean, it was a very easy one that a lot of people got done very quickly. I mean, I knew it was binary search. I don't know why I did try to do it linear, but that would have saved me. I mean, I watched it a little bit, so or a lot, and that cost me a couple minutes. But also just that one permission. I made a lot of dubious decisions in this one, I think. Okay, let's go over the contest. Definitely could have been way better. Oh, I was going to say 200. It's kind of sad, but it's going to go down a little bit because I still have to wait a lot of minutes I guess another 10 minutes. One of the I have to look at my shortcut keys because I submitted one without even knowing, so that cost me 5 minutes, which is probably a good drop. I mean, I'm 43 finishing time. If I didn't have that 5 minutes, I would have finished in, I don't know, 59 or so. I mean, not terrible. I mean, not like exceptional, but not terrible. But still, anytime you get extra 5 minutes for no reason, but yeah, it's gonna drop. Maybe I'll finish top 100. Then it'll be what it is. What it is. Okay, cool. Let's go over the problems. Real quick. Cool. Tic-tac-toe. Yeah, I mean, I basically brute forced here. This build did lovely at the same time. No one really did something exceptionally quick, so I don't feel that bad about it. I mean, even though 5 minutes is a little bit on the slower side, but for me, but I think it's okay. But yeah, it's just simulation. Just do what they tell you, right? So I don't think there's and I literally did all the combinations, which was way error prone, and that's what I was scared of. But it turned out okay. So I was always double checking to see if you could get like X in a row or something like that, but you can't because they just give you the moves alternating. So yeah. Number of burgers with no waste ingredients. I did the math. I thought 10 million would be fast enough, but I guess there are enough cases where that is not true. But the big thing to notice is that there's only both jumbo and small will take up only one cheese slices. So if you know how many jumbo burgers you have, then you know by math how many small burger you have because they share the number of cheese slices, and then you could see if that you have enough tomatoes, and then and that'll tell you. I don't know why I did a linear search, to be honest. Now that I think about it, I just thought it was fast enough. I just want to get it out. Rushed it a little bit, but so it took me 10 minutes, and it really shouldn't have. 10 minutes plus 20 minutes. We're going to count that, but one of them is that like I'll just see what the command enter. I guess that's kind of I need to figure a way to turn that off, to be honest. Because I never want to do command enter. That's not something that I like. That is not something that I need to do. Like I could just click. I rather save the extra frame, but I think because I'm on Apple, so I was playing probably like just pressing tab and then press enter somehow on a wrong window, and then it's submitted without me knowing. That cost me 5 minutes. But once you have that function set up, you could binary search, and I don't know. I think I was just a little bit rushed, and I got stuck on this for a little bit, where it was returning nothing because I just had a while condition incorrectly because I was just maybe a little frustrated by the 5 minutes and just not being prepared. But that's gonna happen. But yeah, binary search. Count square submatrix for ones. So it's I wouldn't say it's a easy problem, but it is a problem I've seen before. Not this one, but it is a little bit standard problem. It took only 4 minutes because I've done the DP version of this, where given a square or given a matrix, find the biggest square, and the recurrence here is that actually I think I'll set a link below, but I've done this YouTube problem before. I've done this Leetcode problem on YouTube. But given that problem, each cell tells you the biggest square that's available ending at that corner. So I noticed that. So I knew that. So that's the recurrence that's here. And then after that, it's counting about the number of squares. And for me, working backwards, it was just, well, how many squares and in that and in that kind of bottom right corner or whatever. And the answer to that is just, well, if the biggest is size, say 3, that means there's 3 square, right? Because there's one of size 1, 2, and 3. And that's how I do the counting from this DP. And then I just sum that all up on the way. So that's why I did it that way. Overall, I mean, I feel like, straightforward. And 386 views solved it, so it's not too difficult. Or at least like if you have that history and you build on it or something like that. Palindrome partitioning. Yeah, I mean, this was a very straightforward DP. I guess I have to go back to see what I spend the time on. I definitely should have been faster. Because I think I knew the DP pretty much immediately ish. It's just that yeah, I had an off by one in a couple of places in this on the really on counting the number of things around the palindrome. So that in a funny way was what screwed me. Because I didn't really change anything. So the code was good to go from the get go. So it only took 14 minutes, even with probably about 4 or 5 minutes of silly debugging. So definitely room for improvement this contest. A lot of silliness. I think one thing that maybe I could have done better in general is just like warm up a little bit. I did just get in. It's not. I mean, it's a little bit of an excuse, but it's also like, well, are you competing at your best when you don't warm up and stuff like this? And I made a lot of silly mistakes here. Silly mistakes. And this one was just a little sad to second palm because I really have no business. I've definitely rushed it. I think recently I've been just so lucky on the contest that I rushed it in the sense that I was like, oh, linear search, 10 million, maybe that's okay. But I think like if I just took an extra couple of seconds, I would have, like if I just took an extra minute, I would have gotten that 5 minute back and just do a binary search because that was pretty straightforward. And I even, because maybe again, the warming up thing, I just had the wrong while loop statement, even though everything else was relatively right. And I was spending time debugging this one because I was worried that was weird, but I was just being dumb. But yeah. Okay, next up, code review. I'm back. The hat is apparently not that lucky. Oh, I don't know. I think it's about 5,000 something. Okay, yeah. So my final rank, 107th. Could have been better. I think if I did the math, I could have shaved about 22 minutes. This includes the 10 minutes of two submissions. And then that would have, like, ideal, like, if I have done everything correct, no silly mistakes, I could have cut off about 20 minutes, 22 minutes, and I would have finished maybe top 15. I mean, of course, that would have been great, but that's not the reality, so we'll see. This is the code review portion, so let's review some code, see what, maybe it's just like read Neo Wu's code is what this section is called. Okay, so he also basically did what I did with actually pretty much exactly the same, except for like minor things, but like, yeah, and obviously C++. Yeah, this is actually, I mean, and this was the other way that I was thinking of doing, which is using for loops, but it doesn't look any cleaner. And like, I mean, it beat me by a couple of seconds, so I don't think I worry that much about it, though. Neo did in 3 minutes, but yeah, usually this is this is tight. I don't know if I understand it. That's actually kind of really cool, actually. I don't know if this is a standard thing, but it just lets you identify things as each row and stuff like that. But either way, still not a big deal. I mean, maybe I could save some time, but I think it just ends up being people are more confident than I was and just submitting it. Here, I mean, it's just a binary search, so I can't imagine anyone's code is that difficult to learn from. So 10 million is too slow, but that's true. I thought about that's a silly miss on my part. So actually, it does linear search, but going the other way instead of cheese slices on tomato slices, and also incrementing by 4. Very smart move. I think the thing that I was, yeah, I mean, I didn't terminate early and stuff like that. So definitely a couple of things there, and that's how you could get that problem in 2 minutes. Wow, in 3 minutes. With just math. I thought there's something like this, but I guess if you sit down and do the math, then that's what it comes out to. Maybe I should have done that. I mean, wouldn't have took me 10 minutes. Oh man, a lot of people just do linear. So maybe linear could have been good enough. I just didn't really, yeah, or just do the math, it seems like. And me trying to rush it end up costing me a great deal. I mean, this should not have been a 10-minute problem given if I didn't have 2 penalties. So that's 20 minutes given to this problem. But yeah, overall, I did learn something. I didn't even need binary search, though it worked. You have just done the math. I should have maybe typed out the math then. But oh well. With paper. So the third one, oh yeah, I mean, I can't imagine this be that different for people. I was going to say that, but yeah, so I mean, this is literally the same thing I did. Maybe. Doesn't need to. I guess there's an implicit thing on the corner actually, so maybe that's not very true. Okay, I guess I didn't remember that part quite correctly. Same thing here. They just do the DP the other way, but same idea. Yeah. No, actually. This one's a little different, but it's not as fast. I mean, it's like n squared times maybe another n-ish. So, but it does show that that algorithm actually was fast enough, maybe with some smarter way of doing it. So it's not purely n cube. It's like n choose 3 or something like that. Maybe. I don't know. Didn't really look at it. Okay. And then now the last one, the one that Neil rooted in 3. I mean, yeah, wow, this is a very tricky one to get. Yeah, that's what I was thinking. But yeah, I mean, this is like I said, shortest path in a DAG, which is a very standard thing to do even bottoms up. I may have gotten a little weirdness with the cost function, but yeah, same thing. It's just that one silliness cost me a lot of time. Oh well. I mean, like I would like to say, well, if a lot of things go wrong and I still finish 107th, that maybe that's not that bad of a contest. I have a lot of silly mistake and a lot of mental blunder, to be honest, a little bit. I thought linear search was going to be too slow, but I just had to be slightly smarter about it. But to be honest, with n equals 10 million, I feel like it's so close to the cusp that like, yeah, I should have been a little bit smarter, maybe even just terminate early. But anyway, yeah, I have like at least 15 minutes of stupid mistakes. I wouldn't go as far as 20. So I think in terms of at least like the part that, I mean, that's the part that's the easiest part to get better at, in the sense that it's just coding, right? So I don't worry that much about it. Maybe so, yeah. So I mean, I worry about it, but that's something that with practice you can get better, and ingrain those things in your mind. So overall, a successful contest. Could do better. Maybe I'll do better next time. Anyway, if you enjoyed this video, hit like and subscribe or whatever. Smash that whatever button, and I'll see y'all maybe next week.